All right, so today we're taking on 4 proofs. We're looking at all of the proofs of these relationships that are built from parallel lines being cut by a transversal. So what I want to remind you is that any time that we see a theorem, it is backed by a formal proof. And the formal proof is really just meant to justify why the relationship is true. So any theorem is backed by formal proof. And what we use to build our proofs, our arguments, we build off of postulates. So postulates are those basic, obvious statements that are so easy to see, we don't need to back them up by formal proof. We also draw upon properties and definitions. And once we have proven a theorem, we can then use it in a new batch of proofs. All right, so here we go. So on this sheet, the first 2 theorems, alternate interior and alternate exterior angles theorem, they're very similar pathways. So my starting point is that the lines are parallel. Line P is a transversal. And we're trying to prove, well, why is it that if we know that these 2 pathways run parallel, why is it that these alternate interior angles, 3 and 6, why do they have to be congruent? So what I typically do is I look at where I'm trying to get to. What's my end game? I'm trying to connect 3 to 6. I'm trying to connect 3 to 6. So the first place for me to look then is to look at angle 3. And I want to think, what can I connect angle 3 to? Well, angle 3 has to be congruent to angle 2. I know that they're vertical angles. Vertical angles are congruent. I have proven it already. So since I've already proven it, I can now use it in my new batch of proofs. So I would write this as the vertical angles theorem. Okay, but that's not the only way that I will take it. If you prefer to write that as a sentence, I'm okay with that too. So if you wrote, if angles are vertical, then they are congruent, I will take that as well. You will always see me model it as what the theorem states. So I usually use the formal rules, but I will absolutely accept it as a statement as well. The goal is to help you be better at explaining how you're connecting the dots along the way. All right, so I've connected 3 to 2. Okay, my goal is to get 3 to 6 in the end. So is there a way that I can connect 2 and 6? Well, yes. 2 and 6, those are corresponding angles. That's our postulate. Our postulate is the one that's very basic, obvious, easy to see. And I can see how 2 could slide into 6's position perfectly. So I can now sync up angle 2 and angle 6. My reason is that they're corresponding angles. So corresponding angles, postulate. And if you'd rather say, if I have parallel lines cut by a transversal, then corresponding angles are congruent, I will take it that way. It's just a lot more to write down. All right, so now I'm taking stock of what is it that I know, what is it that I need in the end. So right now I've connected 3 to 2. I've connected 2 to 6, so I can connect 3 back to 6. I should be able to see that as a 3-way chain, a 3-way connection. And anytime I'm building that chain of 3 or more parts, that's the transitive property. So if I write this out in letters, I could say, well, if I know that A is the same as B, okay, and I know that B is the same as C, well, then it makes sense that A is the same as C as well. And that's true for equality, that's same for congruence. And since we're given a congruent statement, we would say, well, that is the transitive property of congruence. Okay, and one thing that you've heard me say quite a few times is that when I see transitive, I could also argue substitution. So if I backpedal to here, if 3 is the same as 2 and 2 is the same as 6, I can picture this 6 swapping out this 2 and getting to the same conclusion. So I'm plugging in something that it's congruent to, or that its measure is equivalent to, that I'm arguing substitution. So I will take substitution here as well. Okay, property of congruence, since my format here is one of congruence. All right, alternate exterior angles theorem, very similar. So here I know that my pathways are parallel. P is my transversal. I'm trying to explain why is it that angle 1 and 8 are congruent. So for me, I always like to look at what's the first part of it, angle 1. How can I build off of that? So if I look at what's marked in my diagram, the only angle I can connect it to is angle 5. Those are corresponding angles. So 1 could slide into 5's position perfectly and they would match. So I can say that 1 is congruent to 5. They're corresponding angles. So I'm arguing the corresponding angles postulate. All right, so I've connected 1 to 5. I want 1 to 8 in the end. So I'm thinking, well, can I connect 5 to 8 then? Yes, absolutely. 5 and 8 are vertical angles. So angle 5 is congruent to angle 8. My reason would be the vertical angles theorem. Okay, once I've proven a theorem, I can use it in my new batch of proofs. So now I've connected 1 to 5, 5 to 8. So now I can finish that three-way connection and connect 1 to 8. But again, I could also argue substitution. I would take both of them. So this last step would be the transitive property of congruence, or we could argue substitution. Either one is fine with me. So substitution, property of congruence. All right, so like I said, those first two are really similar. We're really connecting the vertical angles and the corresponding angles. Could be in whatever order you want. And then we're finishing up that three-way connection by using the transitive property of congruence. We could also argue substitution since we're plugging in equivalent things or congruent things. All right, next up. So these two at the bottom, same side interior, same side exterior, are also very similar. Okay, I could also say consecutive interior or consecutive exterior. So in these proofs, we're trying to show why the relationship is one where they are supplementary. And supplementary just means that their measures add up to 180. So I'm making that my end game. I'm saying, okay, let's start with the lines are parallel. They're cut by a transversal. Why is it that the sum of their measures adds to 180? All right, so I have given you your starting point already filled in. That's your statement. And I'm saying, well, it's a given. And what I'm trying to get to in the end, I'm trying to sync up angles 3 and 5 and show why those measures have to add to 180. So when I look at my end game here, I usually start off by thinking, well, do I have a pair of angles that also sum to 180 in the diagram that are not 3 and 5? And I see, oh, right here. 1 and 3, those measures have to add to 180 as well because they form a linear pair. So I'm going to start there. I'm going to say the measure of 3 plus the measure of 1 equals 180. Right? What's my reason? Well, I know that linear pairs are supplementary. Their measures add to 180. So I call that the linear pair property. Our textbook calls it a postulate. I will take that too. And in fact, if you prefer to just write it out as a statement, I will take that also. So you would just write a statement that says, if angles form a linear pair, then they are supplementary. That's fine. So now when I look at my step right here and look at where I'm trying to get to down here, the only thing that's different, here I see a 1 and here I see a 5. So I need to swap out this 1 with this 5 down below. So when I look at my picture and I think, well, how are 1 and 5 related? Well, they're congruent, right? 1 and 5 are corresponding angles. Corresponding angles are congruent. I can picture angle 1 sliding into angle 5's position perfectly. So I can say next, angle 1 is congruent to angle 5. Corresponding angles postulate. All right, so I'm super close. The issue here is that I can't put a figure in for a measure. So I have to do a little conversion. So if my angles are congruent, their measures must be equivalent. So the measure of 1 equals the measure of 5. So what enables me to convert forwards and backwards? That's the angle congruence postulate. So that's the diagram that you see me draw all the time. If congruent, then equal, and vice versa. So if my angles are congruent, their measures are equal. If my angles have equal measures, then they are congruent. So it goes forwards and backwards, and it applies for segments as well. So I use it a lot when I'm just trying to convert to the appropriate format. So if my angles are congruent, if the figures match, their measures must match also. So now I'm ready to do a little swap. So I'm going to take this measure of 5 and plop it in for this measure of 1, just like that. Okay, so if I know that measure 1 and 5 are the same, I'm just going to plug in that 5 in for that 1 right there. So I'm closing out using substitution. So this would be the substitution property of equality. So this is one of those rare times, well, I can't argue transitive. I'm not making a chain, right? I'm not connecting 3 or more parts. Right here, I'm literally swapping out one item for another equivalent item. So I'm using just pure substitution for my last step. All right, lastly, we're looking at the same side exterior angles theorem. Okay, we could call it consecutive exterior angles as well. And this proof is very similar to same side interior right here on the left. So in this one, I'm trying to show why is it that angle 2 here and angle 8 here, why is it that they're supplementary? Why is it that their measures add to 180? So I know my lines are parallel. P is a transversal. Can I build my proof to get to this relationship that their measures add to 180? So the first thing that I typically do is I look at either angle 2 or angle 8. I haven't marked anything connected to angle 2, so I got to look over here at 8. And I can see that these angles here, they form a linear pair. Linear pairs are supplementary. That's a great place to get started. So I can say here that the measure of angle 6 plus the measure of angle 8 equal 180. Okay, what's my reason? Well, they form a linear pair, and linear pairs are always supplementary. So I'm going to argue the linear pair property. All right, so now I'm looking at where am I in step 2? Where do I need to be in step 5? So what's different between them? Here I see a 6 and here I see a 2. So when I look back at my picture, well, what's the relationship between 2 and 6? oh, they're going to be congruent because they're corresponding angles. I can visualize how angle 2 can slide into 6's position perfectly. So they're identical. So I'm going to say here that angle 2 is congruent to angle 6. Corresponding angles postulate. All right, so I'm getting really close, right? But I'm not quite there yet. So I really want to put this 2 in for the 6, but I can't do it yet because right now I'm seeing that my figures, the angles themselves are identical. I can't put a figure in for its measure, so I have to do a little conversion first. So measure of 2 equals the measure of 6. So if my angles are congruent, their measures are equal and vice versa. So I'm going to argue the angle congruence postulate. So that postulate helps me convert to the right format. If my angles are congruent, their measures are equal and vice versa. So now I'm ready to do my little switcheroo. I'm ready to substitute. So if I know that the measure of 2 and 6 are equivalent, then I can take that measure of 2 and plug it in for the measure of 6 right here. So all I'm doing is I'm plugging in an equivalent value. I am using substitution. So I can get to my conclusion using substitution, property of equality. All right, have a good rest of your day.